All right, you're good to go.
Yeah. Okay. So, hello everyone. My name is Martin Golasowski. I work as a senior researcher at ITF Innovations, which is the National Supercomputing Center of the Czech Republic. And I will tell you something more about the Lexis platform, which is also part of the Euro-HPC Federation platform, described there as a workflows module. So just to give a quick, just to set the stage for the motivation for having this platform, there is a huge push from both academia and industry to utilize very powerful compute resources, which can be described as a combination of traditional massively parallel HPC systems. With the onset of the AI, we have a massive also GPU clusters with a powerful storage and so on, and also systems which have different modes of access, like the mentioned Kubernetes or IaaS platforms as OpenStack and so on. And we already have those systems either through Euro-HPC or some national or local providers available throughout Europe. And at the same time that there is a huge push from the, let's say, official authorities from Europe to make all the science and research which is happening here sustainable and reproducible and so on. So there is a need really to store data and present them in some meaningful way, collect the provenance metadata and so on. So this would be some high-level overview, and now concretely about the Lexis platform. So now if you want to access some supercomputer around Europe, now you have to select the location you want to use, then you have to fill out the request for allocation, get it approved, and so on. Each location has a slightly different like a bureaucracy behind it. And once you get it approved, then you as a user has to be aware of how to use the SSH, how to use Linux terminals, be comfortable with the Linux environment and so on. Learn about the Slurm, about the batch scheduling, learn about the modules and storages and so on. And I mean, from this is visible that the learning curve for actually accessing HPC is quite steep. And there is probably a better way how to address this, so we can have a nice web interface accessible as a service on the internet, which is the, I think, most common way how we as a users are used to consume services now. It's just there, and you can use this service to access your allocations on different providers on different HPC clusters at once. You can launch HPC applications using a single button. You can specify very simple or very complex workflows. It's up to you. You can get logs, std out, std of the jobs, and of course transfer the data or have an automatic data transfer to and from the HPC cluster file systems. And thanks to this web interface, of course, the platform is available also as an API. And you can use a common authentication method using OpenID. We are connected to two major identity federations. It's the B2Access by UDAT and the MyAccess ID by Jean. And you can use your university login to actually access the platform. About how the platform is actually designed, it's a, let's say, pretty standard three-layer architecture. So we have the Lexis portal and APIs on the top. It's the web application running in the user browser. Then in the Lexis platform core, we have three major components. We have the component dealing with the data transfers and metadata storage, which is called the distributed data infrastructure. Then we have the workflow management orchestrator, which is based on the Airflow and some plugins, and I will talk a little bit more about that. And we have a component which facilitates the AI solution, because all the APIs which we have in the platform are designed as a zero trust, so you need to have a token to do any operations on those. And then each connected site to the platform has a set of integration components deployed next to the cluster, so we don't force again anyone to deploy anything on the cluster itself. We just recommend each of the locations to deploy the integration components in the VM or container next to the cluster in some virtualization infrastructure. And then there are two types of components. One component is called HPC as a Service REST API, which provides us a common API across the centers to manage the batch jobs and their lifecycle. And of course, we have a worker or process which then facilitates the data transfers. The platform itself doesn't have any data storage, it just has a centralized metadata index. Now something about the Hippie. So it's a middleware written in a .NET Core exposing a fairly standard HTTP API, which is connected to OpenID provider, and it exposes endpoints for submitting jobs, preparing job directories, monitoring the job status, and so on. And it communicates directly with the Slurm using the SSH and CLI commands of the Slurm. And it operates purely in user space. So there is, again, no service needed to be, or integration component needed to be deployed on, for example, login nodes and so on of the cluster. As I said before, the Lexis platform exposes the web portal, REST API. We also provide integrations with Python SDK, and the Python SDK also have a standard CLI, command line based interface, and we also have a package for R environment. Now, something about the use cases. We have several, we are addressing many use cases for the platform, both, let's say, for users who don't want to deal with any, let's say, technological complexities of the HPC. They just want to run something on a HPC and transfer input and output data. We also provide capabilities for the users to specify their own workflows. This can be useful for the users who are advanced and they already know how to work with all the specifics, but they just need a system to address, let's say, multiple clusters at once in one single workflow. So one example of this is, for example, the Lightgate project where we actually run where we utilized 4 different HPC clusters in one workflow. And the intention was that there is a company called Dompe from Italy, which has a proprietary binary application which contains some IP, and they didn't want anyone to actually access the application, but they wanted users to be able to execute it with their own data and specify the parameters. And this is what you can utilize the Lexis for. You can create command templates in Hippie and specialized workflow, which can expose this application really as a service, as an API. And that way the users can specify the application parameters, and the workflow will automatically transfer the input and output data for them, and the users don't have any means to actually get to the binary itself. This is how it looks in the web interface, and we also have a video of this demo, and I have the link at the end of my presentation. And for that demo, we used 4 locations. We used a private cluster at the E4 company in Italy, then part was run on Carolina in Czech Republic, Leonardo in Italy, and Lumi in Finland. And Carolina was used for post-processing. Then another interesting use case for the platform is, of course, the, let's say, data management capabilities. This is being used by the Open Web Search project, for example, which uses the Lexis workflows to actually produce open web index, which can be used to build your own search engine or do some other data processing. And the project is using the Lexis to actually create the data sets which contains the actual indices, and anyone who is capable of logging into the Lexis can download the indices and work with them. Another use case of the whole platform is that, of course, we are not offering just a web interface. If someone doesn't want to use the web interface, they can simply connect their own system to the platform, and we did exactly that in a system which is called Floreon. It's a system that is used for decision support in crisis management, and it combines data from 4 different domains, and it can be used to observe how those different domains affect each other. It is especially useful, for example, when there is a flood ongoing, and the simulation of the flood contains a result that says that, well, there will be some road flooded, and then we can use the system to observe how the traffic would be affected over a certain city. Yeah, and of course, the simulations in the systems are run on HPC, and to do that, Lexis workflows are being used. So this is one example, and one example of use case for this kind of platforms. And also the project I mentioned before, the Open Web Search, they, for example, use a completely dedicated instance of the orchestrator. They are just using the integration layer which we built for the management of the jobs and management of the data. They manage the workflows in the airflows completely by themselves. So we have the entire platform completely open, and the users can use whatever component they would like to, they would need. This is an example that also allows the users to specify their own job scripts. So users can still write some bash code or Python code or R code in the browser, and they can use the browser, the front end of the platform, to submit the job script. And this is actually example of a templated workflow. There is a template workflow which contains the steps for data management, job management, and management of the results. And you can essentially submit all of that using a simple click of the button and access the result of the computation. And maybe just to address one of the questions I heard before, we can also modify these tasks and those interfaces to collect additional provenance data, which can contain some information about, for example, the cluster being used, the modules being loaded, the Python packages being used for a certain computation, and so on. Yeah, this is very flexible, and we can accommodate it, and we already have some let's say, effort being done towards this task in some other projects, which are focusing on creating this, for example, these arrow crates or fed data objects and so on, which can be very useful also for the AI domain, yeah, to really capture the complete, let's say, snapshot of the environment in which the actual execution was done. Yeah. So now something.
Left. 5 minutes left.
Yeah. Okay. Thank you. Now something very quickly about how we work with the workflows. So as I said before, we offer the users several ways how to specify the workflow. We have templated DAGs, directed acyclic graphs of the airflow, which contains a predefined patterns for container execution. The HIPI templates, which are the templated command templates, templated job scripts. And then we also have an integration that allows the users to specify the workflows declaratively using YAML files using the CWL and Tosca formats, or the users can define completely custom workflow DAGs using Python. Then once the user will choose the template, then there is an instance of the workflow being created, and this is the place where the user can also specify the default parameters or default values of the parameters, and then he can execute the actual workflow. This is how it's implemented. We have Airflow, Apache Airflow, fairly standard software widely used to orchestrate data-based pipelines. And we created two packages as extensions to this software. We have Lexis Provider, which contains operators that can address the different APIs of the platform for data, job management, AI, and project management. And we also created an API plugin that allows us to specify the DAGs using the YAMLs and so on. Then here is just a schematic of how the data transfer actually works. The right-hand side contains the pieces which are deployed on each of the HPC locations, and there is a staging worker which actually moves the data to and from IRODS zones or some remote storages, just as S3 or, as Henrik mentioned, for example, Simple and so on, as soon as there will be some data protocol available to and from the HPC cluster storage. Yeah. And I think that that's all from me. Thank you very much. Here you can see some links to interesting demo videos which we have online on the YouTube. Thank you very much. Maybe if you have some questions.
Okay, thank you, Martin. Questions?
One from online. Would it be possible to use workflow files from existing engines such as Nextflow and SnakeMake?
Yeah, because we can create custom job scripts and essentially execution integration, which will execute those workflows directly on the cluster. Yeah, we have something that in mind with the CWL actually. Yeah, we have some proof of concept.
Thanks for a very interesting talk. In one of your slides, you mentioned you had a customer and you didn't want the customer to have problems with the intellectual property right. So does it mean you can run a trusted research environment, which would be required for example, patient data, medical data, and all of that? Because that is something which is of high demand.
Yes, I think that thanks to the distributed nature of the whole platform, we can create a completely isolated set of workers and APIs which are tied only to a certain project tenant of the whole platform. But of course, it has an implication that we have to talk to this particular infrastructure and set up the policy or security policies in a correct manner. Yeah, because if I understood correctly, each of those sensitive cloud infrastructures and so on have a slightly different access policies. Yeah, so it's possible, yeah, but can be complicated.
A remark about our experiences on Lumi in that respect, where we have looked at it. The problem to offer a complete secure environment is that the laws in every country, and in some cases I've heard even parts of countries, are different. And that makes it impossible to offer a really completely validated environment that way. So you can do something, as he says, but you cannot offer something that will pass all government requirements and so on. That's simply because the laws are too different.
Yeah. For example, what we can achieve here is that we can set the tenant in a way that the data cannot never leave a zone which is located in some country, for example. Yeah, we can set up a policy that can never happen. Yeah, but again, it depends on what kind of policies we have to adhere to actually.
Hi, Martin. This is Jens from the JC. Thanks for your talk. We are working quite a bit with Airflow, so that's already an important or interesting workflow engine. So I'm happy to see that this is also the core at your side. So I have two questions. One is, what is your motivation to kind of put something on top of Airflow? Because Airflow, you know, the community is very big. You have a lot of movement and especially with the new version, it get really interesting for these setups. So that's the first question. The second would be if users would like to keep these Airflow interface, could it be instead of Lexis on top of Airflow, be the opposite, or kind of how would that work?
Yeah, okay. So to address the first question, I think that we picked Airflow for mainly two reasons. One reason is that it's highly scalable by design. Yeah, can spin up many workers, which then take care of execution of those tasks. And then it is very nicely extensible. It's built on top of Flask app builder. And essentially, it was quite obvious for us to create a provider for our specific APIs. And let's say plugin which extends the API with some specialized endpoints which the users can use to actually create a declarative DAX. Yeah, because Airflow, at least for the version which we are using now, it doesn't have this capability yet. Yeah, so we have to write the DAX. By hand. And for your next question, I think that this is the exact use case for the provider library, and the project Open Web Search is actually using it that way. They have their own Airflow, and they define the DAX by themselves completely. They are just using some operators of the Lexis provider to actually run applications or run some tasks on the HPC. Yeah. And this is also one of the use cases which we offer. Yeah? Then the users need to store some authentication token somewhere in some vault or in the encrypted variable in the Airflow, and they can then use the Lexis APIs directly. Yeah, without the need to access it through the interface of the APIs.
Okay. Yeah. I think it's good if we wrap up here and move on to the next talk. Thank you very much, Martin.
Thank you very much for the attention and for the questions.
And next up is Ilya. So Simon, yeah, make sure he has co-host so he can share the screen. He should be ready in Zoom.
Hi. Yes, I think should have everything.